Katie from Hackster. At Hackster, we know that learning new technologies and tools for use in the classroom can be time-consuming and daunting for many teachers. To help with this, we have partnered with BBC Microbit to create 3 short, informative video lessons that will give you the confidence to use the Microbit in your classroom without wasting time with extraneous details. In this first video, we will cover the basics of using the Microbit, including setting up your Microbit, the features of the Microbit, and some ideas on how this tiny tool can be used in your classroom to teach a variety of topics and help students complete their learning goals. Let's get started. A Microbit is a tiny programmable computer designed to make learning and teaching easy and fun. Studies have found that using physical computing devices, like the Microbit, in the classroom increases motivation, collaboration, creativity, and results in concrete understanding of programming concepts. In addition, the Microbit can be used to teach concepts in many subject areas, including math, science, engineering, and even arts. When you receive your Microbit, it will come in a box like this. Open the box, and you will find a Getting Started guide and important safety instructions. Under the guides, there's a small bag. This bag contains your Microbit. This is the front, and this is the back. If you lift up the cardboard, you will find a USB connector to connect the Microbit to your PC, 2 AAA batteries, and a battery pack. When you are using your Microbit, you can power the Microbit using your USB cable or with the battery pack and batteries. Before you connect your Microbit, be sure to read the safety instructions that are found in the box. Once you have read the safety instructions, plug your Microbit into your computer by inserting the rectangle USB plug into a USB port on your computer. Then plug the other end into your Microbit. When you connect your Microbit to your computer, you will notice that your Microbit lights up. This is the beginning of the demo display. Your Microbit will say hello, and then it will prompt you to press button A, followed by button B. So we'll press button A, and then we'll press button B. Your Microbit will then say shake. If you shake your Microbit, you will see a light display The last part of the demo says chase, and what it means by chase is that it wants you to take a solid light and chase a blinking light. So you'll see a solid light and a blinking light, and you need to tilt your Microbit so you can have the solid light chase or find the blinking light. And you'll do that about once or twice until it's all done. The demo we just saw shows just a few of the things we can program the Microbit to do. We will delve into 2 options for coding with Microbit in our next videos. But first, let's go over the parts of the Microbit and how they work. The most distinct part of the Microbit is the light display, which is on the front of the Microbit. The light display is made up of a 5x5 grid of LEDs, which stand for light-emitting diodes, and can be programmed to display various words and designs. You can program the display to turn off or dim the brightness of the LEDs. There is also a yellow light on the back of your Microbit. This light will flash to indicate that something has changed, like when you upload a new code on the Microbit. On either side of the LED display on the front of your Microbit, you will see a button. These buttons are labeled A and B and are used as input for the Microbit. The Microbit can detect which button is pressed and react to the button press, or send information to another device, depending on how you have programmed your Microbit. The button on the back of the Microbit, next to the USB connector, is the reset button. You can use this button to start your uploaded code from the beginning. The Microbit has a built-in compass that can be used to measure the magnetic fields around the Microbit and determine the direction the Microbit is facing. This feature can be used to turn the Microbit into a compass, or to send directional information to another device, like a robot. The Microbit has a built-in accelerometer, which is used for detecting specific motions and the speed of the microbit. Using the accelerometer, the microbit can detect when someone shakes, tilts, or even drops the device. There are endless ways you can use this feature in your programs, such as creating a pedometer that measures each step taken, or measuring the acceleration of an object by attaching the microbit to a car and sliding it down a ramp, or even just measuring the movement, like a shake, of the microbit to simulate the roll of a die, like the example I have uploaded here. Each time you shake the microbit, the accelerometer detects the movement and the microbit displays a random number from 1 to 6. On the bottom of the microbit, you will notice a ruler-looking feature with holes and labels. These are called pins. There are a total of 25 pins, which are separated into small pins and large pins. You will mostly be using the large pins, which are the pins with the holes labeled 0, 1, 2, 3V, which stands for 3 volts, and G and D, which stands for ground. Pins 0, 1, and 2 are general purpose input and output pins, abbreviated GPIO. These pins can be used for both input and output and can be connected to various devices, such as thermometers or speakers, using alligator clips. You can also use 4mm banana plugs instead if you have those. When connecting your devices using alligator clips, be sure to get the board between the jaws of the clips without overlapping any of the smaller pins. You don't want to overlap the smaller pins. If you overlap with the smaller pins, this may prevent your code from working properly. So make sure that you only connect the big pins in any way without overlapping. Pins labeled 3V and G and D are the power supply pins. Make sure you never directly connect these pins together. The 3V pin allows you to power another device, or if your microbit is not already being powered by your computer through the USB cable or external batteries, it can be used to receive power from another device. Ground is used to complete the circuit if you are using your 3 volts to power another device. There are many possibilities for lessons using the input and output pins to connect the microbit to other devices, such as having your students connect their microbit to a speaker and program it to play a song, or connecting the microbit to a moisture sensor and detecting the moisture level of soil. The small pins are the unlabeled segments between the large pins on your microbit. These pins are beyond the scope of this video, but if you want to learn more, please visit the URL on the bottom of the screen to see a labeled diagram and learn the function of each pin. On the back of your microbit, you can see the labeled BLE Antenna, which stands for Bluetooth Low Energy Antenna. This antenna allows the microbit to communicate with other devices, such as your phone or tablet, wirelessly by sending and receiving signals to and from that device. If you are using multiple microbit devices in the classroom, you can take advantage of the radio feature as well. The antenna also can be used to communicate wirelessly via radio waves to other nearby microbits. Some examples of ways this feature can be used include playing games in teams like rock, paper, scissors, or as an activity in a lesson to determine how viruses spread from person to person. The possibilities are endless. It's up to you what you decide to do. The microbit's microprocessor chip, the brains of the microbit, has the capability to detect changes in temperature. While it does not have its own temperature sensor, the microprocessor chip, which can be found on the back of the board, can detect changes in temperature. This means that while the microbit may not be accurate at recording the true temperature and may be off by a degree or two, it is precise and therefore great at measuring the change in temperature. You can calibrate the microbit to make it more accurate by comparing its temperature reading to an external thermometer and adjusting the code to offset the difference. You can also connect the microbit to an external temperature sensor using the input and output pins. Now that you have learned the basic features of the microbit, you can move on to Lesson 2, where we will teach you how to program the microbit using JavaScript. If you are not planning on using JavaScript and will be using Python instead, you can go straight to Lesson 3. Thank you for watching Hackster Live. We hope you join us again soon.